All right, now we're going to do a test for a difference in two proportions. So up to this point in this chapter, we've really just been working with sample means, and now we're transitioning to sample proportions. So instead of mu1 minus mu2, it's now pi1 minus pi2, because we're now looking at proportions. And of course, this will be estimated by p1 minus p naught, which are our sample proportions. So we need to talk about our assumptions. And as before, we're now looking at two independent populations, so we need to make sure that those two populations are actually independent and that both samples have at least 5 successes and 5 failures. And all we would need to do is take p1 times n1, 1 minus p1 times n1. So this would be the number of successes in the first sample, number of successes in the second sample. And then p2 times n2, so that would be the number of successes in the second sample. Then 1 minus p2 times n2, which would be the number of failures in the second sample. And so we have a confidence interval for the difference in proportions, which will be the difference in our sample proportions, plus or minus z. So recall with proportions, we always use z, not t, which is kind of nice because we don't have to worry about degrees of freedom anymore. And then we're going to use this as our standard error. And then for our test statistic, so it's now z-stat because it's proportions. We always use z. So z-stat is equal to, so it's the difference in proportions divided by this as our standard error. So notice we have this p-bar thing. P-bar is just the overall proportion of successes. So it's just the number of successes in both groups divided by the total sample size. Okay, so let's do an example. So that you'll see this example in the PowerPoint notes. So what's the difference in proportions of Democrats and Republicans who think climate change should be a high or very high priority for the president and Congress? And so they took a random sample of 1,067 US adults. So we have our numbers over here. And we're going to use alpha equals 0.05. And let's look at what we want to test. So do more Democrats than Republicans think that Congress and the president should put climate change as a high priority? Okay, so let's start with our assumptions. Which is that we have independent samples. Just check, because we were told that a random sample of 1,067 US adults. And then we need 5 successes and failures. So to check that, we can do N1 P1, so that would be 472 times P1, 0.78, which is 368. And then we would have N1 times 1 minus P1 for the number of failures. So that would be 472 times, so 1 minus 0.78 would be 104. And then we need to check the second sample, so N2, P2. So our second sample, this is Republican, we have 430. Our proportion is 0.25, and we get 108. And then N2, 1 minus P2 would be 430 times 1 minus 0.25, which is 323. So these are all bigger than 5. Right? In fact, they're a lot greater than 5, and so this assumption is met. So let's start with our hypothesis test, so null and alternative hypothesis. So we think that more Democrats will think that it should be a high priority. So when we start with our alternative, we'll say pi Democrat minus pi Republican is bigger than 0, because we think Democrat is bigger than Republican. And so pi Democrat minus pi Republican is less than or equal to 0. So let's note that this is one tail. Okay, so we need to calculate our test statistic, so z-stat. And we know that this is equal to P1 minus P2 over P bar, 1 minus P bar, times 1 over N1 plus 1 over N2. We'll take the square root of that. So let's calculate P bar real quick. So P bar would be the number of successes in each group. So we calculated that as 368 and 108. So 368 plus 108 divided by our sample sizes, so that'd be 472 plus 430 is equal to 476 over 902, which is 0.53. Just again, number of successes was here and here. That's where these numbers come from. Okay, so now we can plug in. So we had 0.78 minus 0.25. And then we had 0.53 as our P bar, 1 minus 0.53, and then 1 over 472 plus 1 over 430. Take the square root of our denominator. And this is equal to 0.53 over 0.033, which is 15.93. So let's create our rejection region. So rejection region is z-stat bigger than z.05, right? This is a one-tailed test, and therefore there's just one rejection region, and we do not divide alpha in half. So this would be z-stat bigger than 1.6449. So now for our conclusion. So z-stat is equal to 15.93, which is bigger than 1.6449, which is our z.05. And so we will reject H naught, accept HA. So interpretation, there is enough evidence to conclude that more Democrats than Republicans think that climate change policy should be a high priority by the President and Congress at the alpha equals 0.05 helpful of significance. Okay, and then our confidence interval, so 95% confidence interval. So we know it is equal to P1 minus P2 plus or minus Z.025 because we have to divide alpha in half for a confidence interval. And then this is P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. So plug in 0.78 minus 0.25 plus or minus 1.96 times the square root 0.78, 1 minus 0.78 over 472 plus 0.25, 1 minus 0.25 over 430. So I get 0.53 plus or minus 0.055, which gives me 0.475 to 0.585. So we're 95% confident that the true difference in proportions is between 0.475 and 0.585, with the Democrat proportion being larger than the Republican proportion.